Hi everyone, I'm Cole, and today I'm going to walk you through this nice little arc length problem that a student submitted. So let's look straight at the problem. So we're going to find the arc length of the system. It's in terms of two variables parameterized by 1t, and we're given the interval for t here to integrate over. Okay, so the first thing that we need to do for any arc length problem is we need to retrieve our arc length formula to see what we're looking for. Right, so here is our arc length formula for two variables. If you would happen to have a third in the future, you would just add another term identical to this, except switch out this variable for z or whatever the third variable would be, and proceed like you normally would, right? Pretty straightforward. So if we break this integral down here, we know that we need the limits and we need the guts. So we know the limits. Those are going to be 0 and 8. And then the guts here, this is a little bit more complicated. So in order to actually acquire this expression here, I like to ignore the square root just for now and find this expression here. If we try to take the square root too early, it can get pretty complicated. So I like to wait until the very end when everything is out and simplify it as much as possible. So let's find this expression here. So in order to find this, we need to take dx dt and dy dt. Each of those involve taking a product rule, right? We're going to square those quantities and we're going to add those quantities together. And this is the expanded out version that you'll find. I didn't show the nitty-gritty details here because it's pretty straightforward, but I did want to show the expanded out version because as we can see in the next step here, it simplifies down quite a lot for us, which is nice, okay? So first we can notice that this minus 8 cosine t sine t term cancels out with this plus 8 cosine t sine t term. And then we can notice that the sine squared t terms combine, and these cosine squared t terms combine to give us this. So we can extract the 17, and this gives us our nice little expression that we know and love as cosine squared t plus sine squared t is equal to 1. So all of this simplifies down to 17 e to the 8t. And now that we have this expression here, we can plug it into our integral, remembering the square root. It's very important that we remember that. And this is a pretty easy integral for us, right? So we can extract the square root of 17. We know that the square root of e to the 8t is just e to the 4t. And we know that the integral of e to the 4t is 1/4 e to the 4t, right? And then we can take our limits, and then it all simplifies down to this value in the end, the square root of 17 over 4 times the quantity of e to the 32 minus 1. Thanks for listening.